that. You're welcome. All right. Top right, bottom left asymptotes at x and y equals 0. I just covered everything I said before I practiced the podcast. So, what's the only thing that can move 0 asymptotes? Horizontal translations for the vertical asymptote, vertical translations for the horizontal asymptote, just like logs and exponentials. Log graphs have vertical asymptotes, and only the horizontal can move it. Exponentials have horizontal asymptotes, and only the vertical translations can move it. Correct? All right. The other thing that we can talk about is the restriction. So this one I know, x plus 6 cannot equal 0. So x cannot equal negative 6. Yes? We also know that x equals 0 is our asymptote, and we're moving it 6 to the left. So it's going to be at x equals negative 6. There's two ways to prove why that asymptote is where it is. Transformations and non-permissible values. Okay? So I know this one has a vertical asymptote. This new graph has a vertical asymptote. At x equals negative 6. Which also gives me my domain, right? What's my domain then? X such that x cannot equal negative 6. But it equals everything else. That's what XER means, right? Can't equal negative 6, but it equals everything else in the world. How do I get my horizontal asymptote, which is normally at y equals 0? Vertical translation. And where am I moving this? 2 down. So it's normally at y equals 0. It's now going to be at y equals negative 2. Because I moved it 2 down. Exactly right. Which quickly gives me my what? My range. Without graphing this, guys, am I on the top right or bottom right? Top left, bottom left. Without graphing it. Top right, bottom left, because why? There's no reflection. I just have a vertical stretch by a factor of 3. So it's going to stretch that graph, but it's not going to move it into different quadrants. Yeah? It's just the reflections that do that. All right? The other thing we talked about on Thursday was if I gave you a graph, everyone's paying attention? Yeah. Give you a graph, I'm going to give you not the most accurate graph, so please enjoy it. This is going to be a what asymptote? Vertical asymptote at x equals 3. And then I'm going to give you a horizontal asymptote at y equals 2. And then I have to draw your graph somewhere. We agree? Okay. This is going to be super accurate. It's going to be garbage, but that's okay. I'm going to go meow, and then I'm going to go meow. What do I have to give you? Asymptotes and what? A point of some sort, because you use that coordinate to solve for what? The A value. Okay, so I need to give you a coordinate. I'm going to give you 0, 1. Please don't judge me on my graph. Okay, it is not accurate. I'll be the first to admit it. Pardon? On a test, I'd have to give you an actual accurate graph drawn correctly, but we're just doing a quick review of what we did on Thursday. Okay, so we need to have our equation in the form y equals a. If you don't know what a vertical stretch is, we don't know if there's a reflection. We do know that this graph actually does have a reflection. Now, I know my a is going to have to come out negative. Why? Is it going to have to come out negative? Top right, bottom left. Did it move? No. So am I going to need a negative a? No, it's going to be a positive a. So if I get a negative a, what do I say to myself? I'm wrong. Go back, try again. Okay? Top right, bottom left is good. If I put it up here, oops, and down there, then I would have a negative. Okay. So what do I get down here? X what? Everyone's paying attention so that they don't do this wrong. All right. X what? Minus 3. We need to have 3 to the right. And Y what? What do we put at the back? Plus 2, we need to have 2 up. Then I use my coordinate. 0, 1. I'm going to get 1 equals a 0 minus 3 plus 2. Subtract my 2 over. Negative 1 equals a over negative 3. A equals 3. So I get y equals 3 over x minus 3 plus 2. And then when it's an equation, I just send it and hope for the best, obviously. Or do I have an equation of a graph? Equation of a graph, right? So I could type it in, and I would see if it matched my graph. And if it didn't, oopsie, well, you wouldn't match this one perfectly because this one ain't that critically accurate. But you know what I'm saying? Perfect. All right. The next thing we have to talk about, though, part 2 of rationals, is we might have a rational graph that looks like this. Okay? And then we're going to add an open coordinate. We're going to add a point of discontinuity. So it'll be a graph like this with like an open dot here instead. Okay? So what the heck does that look like? All right. There's 2 versions. So this is where point of discontinuity is going to come in. The graphs you might get are a graph where it just has a point of discontinuity, which will be a linear line with an open dot, or a rational graph which has an asymptote, vertical and horizontal, and a point of discontinuity. Okay, so you can sometimes have just a point of discontinuity, or you could have a rational graph with both. So if I ask you to find a point of discontinuity, the x value of the point of discontinuity, that is just your normal acceptable standard question. The moment I ask for the y value of the point of discontinuity, that's standardized. Okay? So let's look at this one. Y equals x squared minus 3x minus 4 over. Now, in order to get a point of discontinuity, I have to have one of the factors in the top be in the bottom. So when I factor the top, I'm going to get what? What are my 2 factors? Yeah, x minus 4 and x plus 1. So I'm going to need to have one of them on the bottom to get a point of discontinuity. I'm going to pick x plus 1. So points of discontinuity happen when the factor in the top and the bottom cancel off. Okay? So I know I need to pick either x minus 4 or x plus 1 to make this question. That's why I can make points of discontinuity questions really easy. I just put a trinomial on the top, factor it, put one of those factors on the bottom. Okay? So I'm going to get y equals x minus 4 x plus 1 over x plus 1. Now some people will say, well, that's an asymptote. That's a vertical asymptote. No, it's not. The moment that these cancel off, that's a point of discontinuity. Okay? I want everyone to type the original into their calculators. So the original, not the one that we just did. The original. Type it in. Go down a little bit. So remember, rational graphs look like they have an asymptote, vertical, and a horizontal, right? That's what we talked about on Thursday. What are you getting in front of your face now? A line, correct? Okay, let's talk about this. What line are you getting? Well, when this cancels off, what's left over? Y equals x minus 4. What do you suppose you have in front of you? The line? X minus 4. Go to y2 and type it in. It's the exact same thing. Go to your table of values now, though. Go second graph. You have two graphs in front of you, correct? They look the exact same, but what's the difference? There's an error at -1 for that first one, correct? Because before I go to cancel these off, remember in rationals, in the unit in rationals, in grade 11, your teacher told you you had to state your restrictions before you canceled off. Whenever I teach rationals, which I haven't got to do in quite some time, what I always say is when you go to do rationals, always slap your hand first and say, have I stated restrictions? If I haven't stated my restrictions, I need to first, then I can cancel. So my restriction, just from here, would be x plus 1 can't equal 0, x can't equal -1. True statement? So either this is a vertical asymptote, which you cannot write as va on a test, or a P of D, which you also can't write on your test. P of D is a point of discontinuity. If you write P of D on the test, you're not getting a mark for it. There's no such thing as P of D except for on your notes, because they're your notes and you can write whatever you want. No short form. Okay? So we know it's either this or this. How do we know which one it is? Well, if it cancels off, it's point of discontinuity, because you're going to end with a line and an open dot. Okay? If it doesn't cancel off, it's a vertical asymptote. That's as easy as it is. So this one canceled off, so I know it's a point of discontinuity. True statement? Now it is a point of discontinuity. It is not just an x value of discontinuity. Correct? Point of discontinuity. So finding the x value of the point of discontinuity, I know that this has a point of discontinuity at -1 and something. Okay? If I ask you for the x value of the point of discontinuity, that's an acceptable standard. 80% of your diploma is acceptable standards, 80 to 75%. 25% standard of excellence. Asking for the y value makes it a standard of excellence. I love these questions when they ask for the y value because it's easy. How do you suppose you could get the y value of a point that doesn't exist? If I plug it into the first step, I'm going to get -1 plus 1, and it's going to be a 0 in my denominator. I'm not getting anything, correct? If I plug it into the second step, I'm going to get -1 plus 1. I'm going to get 0. I'm not going to get anything. So where do I have to plug it in to actually get the value? Into this y equals x minus 4, that linear equation, correct? You plug it into there. So I'm going to get y equals -1 minus 4, y equals -5. Yeah? So my point of discontinuity is at -1 and -5. I can only find the y by canceling those x's off first and then plugging in to find that y value. So guess what, guys? In front of your face, you have a line. What's left over? You have the line y equals -4, y equals x minus 4, but you have to put on here x can't equal -1. This is technically what you have, right? You have the line x minus 4, but -1 doesn't exist on it. We agree? So if I went to draw it, I go to -4, I put a dot. How do I draw this? Well, the slope is 1 over 1. So remember, you rise before you run out of bed. If you run before you rise, you're just running in bed. You look weird. So remember, slope is rise before you run if you're late for your school. So we're going to go up 1, right 1. We could also do the complete opposite. We could go down 1, left 1, because these could have both been negative, and the negative signs would have went away. So I'm going to go up 1, right 1. 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 Well, what am I going to do here? Still do it. What about here? Up 1, right 1. Okay, what about here? Down 1, left 1, going the opposite direction. You're going to have an open dot. So you're going to have a line like this. In your calculator, does it scream open dot to you when you look at it? No, it doesn't. You have to remember there's an open dot. So this is our one type of rational. This is our first type. a rational with a point of discontinuity, where the numerator is a greater degree than the denominator. So the first type is numerator degree is greater than denominator degree. When that happens, you get a line with a point of discontinuity. That's it. Because once you cancel your point of discontinuity out, all you have left is a line, right? In this case, it was x minus 4. Do you agree? Our second type is where the numerator and denominator degree are the same. I'll come right back to that one. Okay. So how could we compare these now? Well, the numerator degree would have to be, let's say it's degree 2, they have to be degree 2, but this one will use the same numerator, x squared minus 3x minus 4. We agree? We're actually going to use the exact same question, we just have to add a little bit more to it. So on the bottom, I'm going to have x plus 1. So is my point of discontinuity changing, actually? The x value, isn't it? I need to add another something to the bottom to make this be a rational, because it has to be degree 2 over degree 2 to get an asymptote. Okay? The only thing that I cannot add to the bottom is the other one of these. Like, I can't make it be the same. It would completely cancel off, right? So I know that this factors to x minus 4, x plus 1. So if I have x plus 1, I can't have x minus 4 here. I can have anything else, though. Anything else. I'm going to choose x minus 2. Cool. We're going to go with what you said. Give me anything but x minus 4. Okay? So let's factor it out. We're going to get y equals x minus 4, x plus 1. I'm going to rearrange these because I like stacking them on top of each other. X minus 2, x plus 1. Oh my goodness, these cancel off. The moment two factors cancel off, I have a what? Point of discontinuity. My point of discontinuity is at what? -1 and something. How do we find the something? What do we always do? Plug it back into the first step? No, it won't work. Plug it back into the second step? Still have the factor. I have to plug it back into this one. So I'm going to go y equals -1 minus 4 over -1 minus 2. So it's -5 over -3, which is 5/3. We agree? So the x value of the point of discontinuity was the same, but the y isn't the same because it's a different graph. It's not that same line, correct? All right. So I know I have two non-permissible values here. Do you see them? I have two denominator factors. I don't know what I was going to go with. So I have x plus 1 can't equal 0, x can't equal -1. It canceled off, so it was a p of d, which I'm not allowed to write on a test. And then I have x minus 2 can't equal 0, x can't equal 2. Didn't cancel off. What is it? It's a vertical asymptote. And it's at x equals 2. Can you type the original into your calculator, please? The original, nothing that you've touched. Because you don't want to put in the one where it's canceled off, because then it won't show the point of discontinuity, right? You always type in your original. So everyone type in the original. So, you're going to get a rational. It has a vertical asymptote at x equals 2. Where's the horizontal at? Where do you think it looks like it's at? The vertical? Vertical should be at 1. Y equals 1. When they're the same degree, it's the number that's in front. So you can say horizontal asymptote y equals 1. Because it'd be 1 over 1. Now this is the full form one that they don't often give you. I'm going to show you what they do give you. Oh, and before I show you what they give you, let's talk about one thing. What would my domain and range be? Most people mess this up, guys. I would star the domain and range because you guys forget some values. When you have a point of discontinuity in asymptotes, you're going to have two values that it can't be. X can't be what? -1 because of the point of discontinuity, and -2 because of the asymptote. X and L in the reals, right? Your range then will also have two values it can't be. Y can't equal 1 because of the asymptote, and what else? It's the one everyone forgets about. 5/3. The y of the point of discontinuity. It also doesn't exist. I want to show you what form they usually give it in. They usually give it in this form. Y equals 3x. Ignore that. Y equals 3. I could do that. X minus 4. And then x squared minus 3x minus 4 plus 6. This is usually the form they give it in. If I give you a separate one. Because what they do is they'll factor it. Let's say it's like this, right? These cancel off, so what do I have? If those cancel off, what do I immediately have? Point of discontinuity, P of D, which you can't write short form on a test, at 4 and something, right? And then I have it in this form now. This is the form from Thursday. What the heck? Why did I write a 6 down? This would get me my vertical asymptote at x equals -1. This gets me my horizontal asymptote at y equals 6. This is my vertical stretch, right? This form's a little bit easier. How do I get my point of discontinuity, the y value? I plug it into this one. So I go y equals 3 over 4 plus 1 plus 6. Y equals 3 over 5 plus 6. Common denominator. Y equals 33 over 5. Now, before you jet off,